Excellent. So, I want to welcome everybody. Thank you for coming to the Xen User Summit. I was wondering how many of you folks are interested in more of the how the process works, how we get a release out, how it compares to, for example, a Linux release or other open source releases, or how many of you are more interested in knowing all the feature-rich features we are going to have in Xen 4.5? Is there a preference for the feature reach versus like how the whole process works and what's behind it? Okay, I seem to have an equal amount, so I'll cover both. If you have any questions, just ask me. I will probably go fast because I get enthusiastic and I just keep on going. So if you have your hand up and I'm not recognizing you, just wave it and I will stop as much as I can. All right, so my name is Konrad. I used to be the maintainer on the Linux code of the Xen subsystem for 2 or 3 years, along with Jeremy Fitzhargener. We both were trying to upstream all the classical Xen patches up into the Linux distry so we would not have to maintain them, or rather, distros would not have to maintain them. With the benefit of that, instead of us focusing time on maintaining and kind of revving them up, we can actually focus on features and fun things instead of backporting and so forth. So that's what I used to do, and I've switched over to working now on as being the release manager, which is an interesting position. We've kind of gotten this position switching over a couple of last years. It's been building up and building up. I won't go really back in the past, but we've been adding up extra things we want to do as a release manager, all the responsibilities. Now, there's this tracking the changes, there's looking at all the bugs. The whole goal of this one is to make this process so simple that there is no need for a release manager, and an automated bot could do it. That's actually a dream, it's not going to happen, but that's a kind of goal. We want to make this as easy as possible and as clear to everybody where we are in the stages of a release. We've been focusing a lot on that one. We have been putting it on the mailing list, on wikis and so forth, and educating people of where we are and what can be done to make this process better, or taking also input from the community. The one thing that I actually have to stress that we've been really not that great about is engaging the Xen users community. We've been posting out like, oh, here's the release, please test it, but not really. Well, we've been following up when somebody has a bug. We definitely want to get that done. And that actually comes into one of the things that is very important as a Xen project. We want to make this release awesome, and we want to make it regression-free. So anything that was working in the past, it should work in this release. We don't want it to break. So my job as the release manager is to do all that, plus I also want to focus on performance. We just want to make sure that the performance of the hypervisor and the tool stack is better than it was before. The other notable thing is, in the past it used to be a Citrix employee, but now since, as Xen is kind of decentralized, we're decentralizing the release manager process too, so now it's a non-Citrix employee. All right, Lars touched a lot of what I'm have on this slide, but I'll just point some interesting part about it. The roadmap is an interesting problem because I have absolutely no control of what goes into a release. I mean, I do after a feature freeze, but before then, everybody is welcome to push as much as they want. If they have a feature, by all means, please push it, please push it. When a feature freeze happens, we stop. And in some way, this is actually very similar to what the Linux release has. Every 3 months, Linux releases a kernel. And the way it works is, he opens a merge window, it's 2-week time, and you can kind of think of it as a train. You get on a train, and suddenly within those 2 weeks time frame, the sidecars have expanded to 4 sidecars. It's going a lot faster, but it's missing toilets, right? And you realize something is wrong. Those 2 weeks suddenly elapsed and you're still without a toilet, and then suddenly things get reorganized. Instead of being 4 sidecars, it's 2 sidecars, the toilets are back, but they're actually Japanese, so it's awesome, and all of that. In some way, it's the same way with the Xen project. We want to get up to the feature freeze, but that 2-week time window is much larger for us. We try to do it 3 months because there is just a lot of things we want to make sure we get a good amount of quality so that the time when we actually start rolling, those toilet seats are in the train. When features are coming in past that, there are exceptions. People can ask, hey, I think this feature is really important. I think you'll greatly benefit the project. I think you'll greatly benefit everybody. And we can kind of go back and forth, but the criteria are pretty simple. Yes, does it benefit the community? 2, is it technically sound? 3, will it possibly introduce regressions? And if so, what's the impact? Like, is it a big invasive change? And if so, how long will it take us to find those minuscule bugs that might impact it? Or is it a feature that just tacks on and it works without really much trouble, and it's, if there is a problem, it's easy to fix it. So we have to take these criteria into mind when actually getting a okay on the exception. All right. Now, I skipped over the agenda because you guys probably already know what's going to happen. I'm going to talk about what's going in Xen 4.5. And one of the things that's interesting is, like, how do you get a release out? As I said, I have absolutely no, well, I have some, but I can't tell Susie or Citrix, you must have this feature by September 21st. That doesn't work in open source community. It works maybe in a closed source internally if I'm a VP, but that doesn't apply. So in open source, it's more like somebody comes in a patch, we try to work it, but if it doesn't cut the time, well, tough luck. It'll come on the next train. It'll come on Xen 4.6, which is okay. It'll be a bit late, but it'll come. That's fine. Or we could extend the cycle. We could make it, instead of making this full 9 months, we could make it 10, 12, 13. Granted, the problem is by that time we have so many features, it's hard to keep track of it. And worse yet, if we have bugs, it's so hard to unravel which ones are which. So we decided on a compromise. 8 months, sound perfect. We actually had a little slippage. Feature freeze was supposed to be September 10th. We moved it by 2 weeks, so it's the 24th. The RC1 is still set on the same original time, and I hope we'll achieve it. There will be no slippage, and that is the day that I hope we can get it out, and there will be no bugs. It will be fantastic. Can you imagine RC1 without any bugs? Yeah, it's unheard of. There will be bugs. But hopefully they're so minor that it's going to be a piece of cake. Now, the neat thing is about Xen Project that I haven't actually found in some projects, but not all of it. We have 3 different mechanisms to test for regressions. We have one that Linux kernel maintainers use to test Linux kernel, different versions, against different versions of Xen to make sure nothing breaks. Then we have OSS test, which tests Xen with different versions of Linux, so the latest one with different OSs and so forth. And then we have Xen RT, which we're developing, which kind of does also performance and has automated tests and so forth. All of those 3 kind of make this a very broad picture of how much you can test and how much we make sure that things just don't regress, because we don't want it. But the other disadvantage of having Xen Project is that it's huge. It has so many projects. It has the hypervisor, it has the tool stack, it has QEMU in it, it has grub2. There's so many different things that can actually be as part of a release. So I've gone and kind of shepherded this by focusing on the Xen Project, tool stack, QEMU, and then some other ones, and the other ones are more kept as informational basis, as in by the time December 10th rolls on, this version of Xen Project should work with this version of grub or kernel or whatnot. All right, questions? All right, so I will jump first to talk to you about what is happening in the ARM ecosystem. The interesting thing, here's a big question. How many of you folks are more familiar with x86 than ARM? Like, if I told you a motherboard, X99 chipset, or you would immediately know what it is. All right, how many of you would say, I know ARM, I know what QB truck is? Oh, okay, well, there's actually a good number. Okay, all right, so one of the interesting things about ARM ecosystem is that they don't function like the x86 world. x86 world, you had a motherboard, you had a chipset, you had CPU, they kind of came together. Or a OEM picked a motherboard, the reference one, and it slapped in the chipset, another one. But all of these features were kind of driven by the CPU vendor. Now, Intel has a chipset and a CPU, and they give it to the OEM. The motherboard manufacturer makes it up, and then it sells it, and everything comes along. ARM is a completely different beast. They decided that what they do is they will send you intellectual property, and you get all this on the SoC. One chipset will have all of these things you need, nothing more. And so it's kind of a one-off base. You release the product along whole motherboard with all the stuff in it, and the manufacturer is the one who's manufacturing, is selling it as such. So they're free to customize what they want in the hardware. They can say, well, you know, I don't need to run more than 8 CPUs, so I'll rip that part out. I don't need power. Who needs power states and you know, going with CPUs now? Nah. So they have this option of choosing and picking as they see fit, which means from a Xen perspective, you can't really say, well, we support X, Y, and Z. It's more like we support these intellectual property, and if your motherboard supports these, then these functionality will run. So I'm going to go through some of them. Some of these are kind of, you know, boring. For example, with Super Pages is interesting. It allows you to run bigger guests at a smaller footprint. The need for it to pass through. We were wondering whether we're going to have PCI pass through on ARM, except ARM is interesting because they're coming out with their 64-bit version, and it's not yet out, and they're going to have PCI cards in it, but that's not yet out publicly. So it's like, well, you know what, we're going to skip that, and the next version we'll try to get this feature working. But right now, you can use device assignment if you want to guest using just the memory addresses where your card is. Perfect. There's features when you do this PCI pass-through, MMIO pass-through, to also have where the guest will actually, if it's moved to a different socket or a different CPU, that the physical interrupts move with it, or the virtual ones. And that's been a lot of work in that side. Here's a bunch of acronyms that you will not memorize, but you will probably look at it and say, oh gosh. And then we say, okay, well, I can look at this and look at the motherboard and say, does it have gig V2, V3, SMMU, blah, 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 blah. Yes, you can look at this and say it has what it doesn't have. Some of these are compatible, so if it's you know, SMMU, which I actually forgot what it stands for, but V2 is compatible with V1 and so forth. That's usually the case. All right. Now, I did tell you that some of these are, you can't really figure out which motherboards are which, but I lied a bit. There are some that it's pretty obvious which ones will be supported by Xen 4.6. So here's your list. If you want to know, or you look out on the eBay or whatnot, and you want to purchase an motherboard from these ones, the one I seem to have forgotten is the Cubitron, but that's fine. All right. So that's the ARM world. No questions about that. All right, great. x86 is an interesting thing because we all kind of know it. One of the things that Xen had a trouble with, or not didn't have a trouble, we have EFI support, but it's been a little bit rocky. For example, if you wanted to use grub2, secure boot, Xen, and Linux, it doesn't work very well because grub2 mechanism for doing EFI bits has been not upstream, meaning no Linux vendor, Red Hat, Debian, SUSE has actually upstreamed their patches for grub2 to work with Linux kernel. They all are incompatible in some way or another. So all different distros have their own way of doing it. We're trying to look at where we're just going to have one option in grub2, which will work with us and other OSs that can also use it. But in the meantime, there is a solution. You can use, without using grub, you can just use EFI EFI NVRAM parameters and say, hey, I want to load Xen with these things, and it'll load. That is something SUSE, for example, offers. But we want to have it completely working with grub2, and that was something we wanted to do for Xen 4.5. It's probably not going to happen. It's mostly Xen 4.6 by now. There's a bunch of fixes where we want to fix up how the guest high precision event timer, so the timing of interrupts based on time goes into the guest. That is something that we had done. The other ones that are kind of interesting and a little bit is kind of neat actually is this thing called VMware backdoor calls. What it is VMware has this tool, VMware guest support. You can load it on your guest, and it allows you to do certain operations and talk to the tools. What Verizon has been looking at is taking that and kind of, not migrating it, but kind of, if you take that image and you plop it on Xen, it will run without modification. So you can take your VMware image and just stuck it on Xen. And they're slowly working through all the kinks of it, but their goal is to have it in Xen 4.5. The one interesting one, one of many interesting things is performance. So as I mentioned earlier, we've been focusing on maintainability at some point, and then we said, oh, too much work. We want to focus on something really neat, something we can write, and then we can introduce bugs in it, then we can fix bugs. Okay, maybe not the fix and introducing bugs. But anyhow, the point being is, one of the things we realize is Xen is awesome, but it has some things that we just need to have so we can figure out where stuff is kind of a bit rotten. And one of them is performance tools. We needed some way to say, when we run these guests and we're doing these certain operations, Xen is not behaving as fast as it should. What do? We need performance tools. So we've been looking at taking the one that seems to be used predominantly today is the Linux performance tool and making it work with Xen. So now you can kind of, the goal is to make it run with Xen. So you could be in your DOM0 and you could see how much the hypervisor is spending, or you can see how much DOM0, or how much the guest, or all of them above. So you can get a whole view of the whole universe. The other thing is we wanted to expand on these big machines we have, like 8 sockets. We wanted to be able for the guest to take advantage of it. The Xen hypervisor already does a phenomenal job of scheduling guests on these sockets and big machines and kind of doing the right thing. But if it kind of spans 2 sockets or more, meaning 2 different NUMA nodes, we want to be able to expose that so the guests can take advantage and they can use their native calls for their application to take advantage of it. Since I work for Oracle, you can probably assume that you will know which application that is. All right. Introspection of guests. This is a cool feature by Bitdefender. They are looking at making a rootkit detection system so they can, when you run your guest and suddenly it's doing something it shouldn't be doing, not only will detect it, but it will also neutralize the threat by altering those instructions in flight and saying, no, you can't do it, and you're just not allowed to. It's a pretty neat concept, and as Loris mentioned, there are some directions we hadn't thought about, but people are like, oh yeah, this is obvious. It should be done now. So it's going into Xen 4.5, pieces of it, and as time goes by, more and more things will be done. If you are a sysadmin and you run Xen and you just suddenly got your 1 terabyte machine and you say, and you reboot it and you look at the clock and it says NUMA scrubbing memory, and you come back in 10 minutes and it's still saying scrubbing memory, that has been fixed. All right. These ones are, they're kind of interesting, but one of the, I'll skip over alternative assembler. I'll tell you about that later. We've kind of expanded as developers. We like to be able to see the serial port, and the reason is I guess, I don't know. It's easier for us to figure out things based on the serial port, so we expanded that a bit more. We've also going to add a real-time scheduler, which is pretty neat because the one that existed in Xen was a little bit rotten, to say the least, and now we have a new one that's going to make it much, where you can actually set the time slices, the budget, and do a lot of interesting things. So it will allow you to run guests at a specific time slots and time slices and all these algorithms, all these parameters you can define. All right, that was kind of the generic stuff. Vendors, of course, like to make sure that their CPUs run the best on the new on Xen and other operating systems. So these are some of the new things that are in chipsets, and Xen is taking advantage of it. The one neat thing is, when you're doing PCI pass-through, for example, you want to do as least amount of time spent. Sorry, you want to spend the least amount of time inside of the hypervisor as possible, because it takes time. You want it all in the guest. So for example, with PCI pass-through, when interrupts were coming through, it went up to the hypervisor and then back into the guest. It was a small amount of code, but nonetheless, it is still there. VAPIC allows you to actually not do that at all. There is no way, there's no mechanism, there is a mechanism, but we don't exercise it to exit out of the into the hypervisor. We're also looking at something where you can monitor in a cloud environment how much cache is the OS using, the guest OS. And you can also limit how much it is. So you can really define your parameters of, okay, I want, there's this service, this amount of service ability this will have, and this is how much it will have. All right, there's some other features that Intel is pushing that have been added in. For AMD, there's the same thing. We wanted to make, oh, PVH, I totally forgot about that. So, PVH, if you go back 10 years ago, when Xen came about, there were no CPUs with virtualized instructions. So we came up with the type of kernel called per-virtualized, and it's a bunch of, instead of making native calls to change certain low-level operations, we make a hypercall. Well, Fast forward to now, and those hypercores, the amount they take, even with batching, is more than if the CPU was doing it with their own CPU virtualization. So we've been chopping those pieces and making it so that a new type of gas, PVH, para-virtualized hardware, can run on modern CPUs without doing those excessive calls. And we have it working on Intel. We're working to make it working on AMD. And for some of the AMD hardware, we're making sure that you can also do debuggability. You can do better job of debugging a guest if you want to run that. All right. Tool stack. All right. Well, let's see. One big piece of code rewrite that's been happening has been the migration support. We have this migration that exists, but we found bugs in it. Citrix has been looking at this and they said, we need to fix this. And they've been doing a phenomenal job of ripping out code and adding new one and redesigning, making a design document for it, really doing a great job. And not only is it doing a great job from a maintainership, but they're also making it faster, 50% faster than it was previously, which is awesome. And the other thing is Remus. So Remus though I'm still not sure if it's going to go in or not. It's still, there were a lot of acts added on, but it's still not clear to me whether the whole thing or a subset goes in. Remus is a way of making, running guests with data checkpointing, so that you can run your guest right here, and you can run it on another co-location miles away, and if this co-location suddenly loses power, your guest keeps on going on the other side. There is a blip of time of 500 milliseconds where whatever was done is lost, but you can kind of replay a lot of what will be happening. So it's kind of goes back in time and resumes operation. All right. The other things have been just adding things. Some of these are new features. For example, SCSI has this feature called trim. Sorry, ATA drivers have this feature called trim. On SCSI, it's called unmap. The generic name is discard, so we added support for that, so you can disable or enable if you wanted it. We also have added a way to keep the guest configurations in Excel. We switched over from XenD. We've actually removed it completely out of the code base, and we decided, hey, there's some things XenD offers that Excel does not have. One of those is keep persistent guest configurations. XenD had that, Excel doesn't have it, so we're working to add that in. And also, since now Fedora has been really pushing on systemd, and we also want to make sure that Xen works great with systemd. There's been enhancement to add the systemd scripts into the code base. All right. The other sub-projects, and how much time do I have? You said 20 after or 30? 4 more minutes. Okay, I'll go very fast. libvirt. So libvirt is an interesting piece of code. It's used by OpenStack, it's used by virtmanagement, it's used by Versh. And what it has, it calls Excel, or the tool stack that we have in Xen. And the features that I've been adding to make it work are slowly expanding. Every month there's a new release of libvirt. And as this keeps on expanding, more and more features are happening. This is a list of some of it, but there's more and more features being added. What it means is that you can easily now launch a guest using Versh or OpenStack than it was previously done. So these are more on the side of like, well, we want to make sure that everybody can use our tool stack, but we also want to make sure that the upstream people that are outside the kind of the Xen project can use it. So we have to make sure that the application programming interface is stable and doesn't break across releases. So it's been a work on that one. All right. So another project that's kind of separate is QEMU. QEMU is what we use for emulating of a guest when it launches in a Windows usually will use this. Linux can also be launched under this one. And one of the things that have been added into is, well, if you want to do PCI pass-through, and you have tons of these devices, and they're 32-bit and they're ancient, but you still need them. For example, if you're telco or Verizon, you might want to have these, and you're running your own operating system like BSD, then you want to have this, and you want to have a large area of memory that's just focused on making it available for you PCI devices. That's been adding in. The other thing has been looking at Intel, their graphics driver to make them work as a pass-through without trouble, and I've been working focused on making that one. And lastly, UEFI is shaping up, and one of the things that's going to is going to happen is they're going to have a block driver, and to launch a Linux guest using the Xen block driver in EFI. What that means is when it launches, instead of using the emulated layer of IDE driver or so forth, it can use actually the Xen block driver to get data. It means faster, it means less problems, it means easier to launch guests. It's pretty awesome. And also the same, we hadn't had this before because there was no need for it. On ARM, we didn't use QEMU because there was no need for emulating. But for some things, and we still don't need it for emulating, but some of the backend drivers that exist, for example, the frame buffer, don't exist in the kernel, they exist in user space. And one of these is QEMU frame buffer. So this is also known as the VNC backend. Okay, as Xen 4.5 is going, there is also releases of Linux that are happening. And I think by December 10th, Linux 3.18 will be out, maybe even it might be 3.19, RC3 might be at that time too. And some of the things that it will have is, for example, now if you get Linux 3.17, which is still in RC4, you can run it with Xen under EFI. It's mentioned you can't do grub yet, but you can run it as Xen and then EFI. So you could use secure boot, Xen EFI, and then Linux and boot it up. There's been also enhancements into the performance of the network layer to make it faster and better. And also we're looking at block. We've been looking at the block backend to make it faster as well, and make it consume less, actually to spread the load of it so it can do better support. And also, as I said, make the support for PVH work better. All right, and these are kind of referring back to what we're adding in Xen. The other operating system is also taking advantage of some of the things that are going Xen 4.5. And as the last thing, I'm talking about grub 2, and this is adding this multi-boot protocol into it so that it can boot Xen hypervisor. All right. You guys have been very patient with me. You haven't asked any questions. There must be a question you have. Okay, great.
I have two. One was, you mentioned that we're moving away from virtualized servers.
No. I meant that there's additional stuff happening in that virtualized. It's not just about virtualized servers anymore, it's actually about virtualized data centers, which includes virtualized network function, memory, and so that's kind of what I meant. Sorry, I didn't mean to scare you.
Yeah. No, so this is kind of referring to Intel DPDK, which is their own driver that doesn't want to use the kernel anymore. They just write the driver in user space that talks to the PCI card, and it pulls, which has this awesome effect that the latency is there's no latency because it pulls it, but it eats CPU cycles like bagels, and it eats it and eats it, but it gets the packet and the application is built straight into this DPDK. So it launches, and within its time frame it gets done and can loop around. So it's incredibly fast and incredibly low latency, but sucks in the CPU usage. But Intel was looking at it and putting in a guest, and there's a couple of things that they found. Well, for small packets, there's some problems, so they were looking at expanding and making it work better. Yes, sir.
So, last question is, Amazon AWS, the EC2 instances, you could scale out, but not up. And I was told that it's because they use Xen and it doesn't give you that ability to scale up.
You mean as in type of memory you have?
More memory, more CPU.
No,
scale
it works.
Up doesn't allow you to scale up.
So their model of running Xen or guest in Xen is interesting. They do similar to what Verizon does. It's like they basically run it on the machine and they say, okay, we're going to put 5 guests on it, and this is the amount of memory we're going to put into it. And then if you want to switch to, so Xen has no problem saying you want more memory, though it has to be pre-allocated. You have to, in the guest config, you have to say, oh, I might want 20 gigs, but right now I just want to run with 5 gigs at boot up time, and you can go back and forth. It's not a problem. The same thing with KVM. You launch it and you say, or I think VMware too, you say how much memory I have at boot up time, and then in the future I want to expand or lower. And I think Amazon just doesn't offer it because they say, well, you probably are not going to use that extra 15 gigs, so why even bother? If you want to, you can just, I think they should have offered you an option to kind of shut down your guest and change your configuration, say,
Shut it down.
yeah. So Xen can do it. It's been existing for 7 or 8 years, and the same thing with other virtualization. It's just how they present it to you. Does that make sense? It's their policy. All right, cool. Yes, sir, in the back. Oh, there's one here too. Okay, let's go for you. And there's a microphone walking around. Well, Russ is working my microphone.
Does this mean that PVH is basically done? We can just start using it?
So the idea with PV, so there's a couple of things. There's PV drivers, and there's the PV parts in the Linux kernel, the core code. PV drivers will exist because they do offer better performance and throughput than emulation. PV, as in the core components, for example, Linux kernel, are going to slowly be phased out. The idea is in 5 years, or 6 years, depending, when we get it, the PVH to be a stable environment, we'll phase it out in the Linux kernel, which means it will be probably by Linux 4.5, I don't know. These, Linux is, at some point, they decided 2.6.39 was too big, and he moved to 3.0, and now we're at 3.17, so, it takes 6 years from now, gosh, it might be 8.0. So it's going to happen in 6 years. We're going to chop off pieces of it, not the whole thing, just pieces of it, the ones that are related to memory management.
But we can use PVH now and not use PV
Yes.
if we want to.
Yeah. You can use it. It's still kind of an experimental, which means that if you run it and you see bugs, you must report it on XenDevel so we can fix it. You had a question, Jen.
Can you just briefly address minimum hardware requirements for Xen, and this would be for testing, not production system?
All right, so are we talking about x86 or ARM?
86, x86.
x86. I run it on my laptop, which is, a Core i3, so you can go as low as you want and as high you want. I mean, it works fine on dual core, even the old Core 2 Duo work fine with Xen with 2 gigs or 4 gigs of memory. It really depends on what you want to run. So Lars touched about it, but these OSV or mini OSs. So imagine a little kernel, a little guest that's like 32 megs running and doing your web, or being your Git tree, or being your DNS server, all contained in one single small guest. So you could, run on a 1 gig machine and have a whole bunch of them. Your initial domain might need only 256 megs. So you can do the minimal amount you want. The problem becomes more of like, even if you install right now Linux on a machine with 512 megabytes, it will complain it'll run slow, but it's feasible. The same thing. Xen doesn't have that. You have the ability to run guests at a minimal amount of memory. For example, our machines usually come with 2 gig or 1 gig, and you can still launch a whole bunch of guests. So you can go low, you can go high.
Okay, thank you. Since we are just coming back from the break right now, according to the clock, so we're going to make a slight adjustment to the morning schedule. First off, let's thank Konrad.
Thank you.